packet to question 9. (50-50) chance. I do not know where they're going to put it. It's possible you can have a position, velocity, acceleration question on the calculator section, like on this one, like in this year, 2016. Or it's possible that they'll put one on the non-calculator section. I'm almost 100% sure that you will get a position, velocity, acceleration, because it's one of those that is pretty much almost automatic. So let's go through it and see if we can improve on our game. Cool. All right. So first and foremost, do you have a calculator? Okay, grab a calculator, guys. Grab a calculator. There's some calculators over here. No, you're good. You're good. You're good, miss. I get it. Trust me. All right. Here we go, guys. It says, for t greater than or equal to 0, a particle moves along the x-axis. So I'm either moving left or right. If you want to put that, you can. You don't have to. You're either moving left or right because you're on the x-axis. The velocity of the particle at time t is given by, so they give you a velocity equation. Since you have a calculator, the very first thing I would do is I would insert that into y1. The particle is at position 2 at time t equals 4. So that means at 4, comma, I'm at 2. This is your time value, t equals 4. This is your position value, position. And that's, so you can write it like this as well. You can write it as x of 4 equals 2. Okay, nothing crazy. We haven't done anything yet. At letter A, at time t equals 4, is the particle speeding up or slowing down? Okay, so let's talk about speeding up. You're speeding up whenever the velocity and acceleration have the same sign, because the acceleration is in the same force as velocity. Is the same force? It's in the same direction as velocity. Does that make sense, guys? So if velocity is positive and acceleration is positive, you're speeding up. If velocity is negative and acceleration is negative, you're speeding up. If velocity is negative but acceleration is positive, see, the acceleration is in the opposite direction, the opposite force, the opposite direction of velocity, you're slowing down. Does that make sense? Okay, so here we go, guys. Type that into y1. So I'm going to take my calculator and I'm going to go y equals, and I'm going to go 1 plus 2 sine, and then I'm going to push alpha y equals. Make it always look like the graphing calculator, or like the symbols here. T squared over 2. So I'm going to go x squared over 2. And there it is. And here we go, guys. Second quit. I'm going to go, here's what you're going to do. You need the velocity at 4. So I'm going to go v of 4 equals, and I'm going to put the velocity. So I take my calculator. I'm going to go alpha trace y1. I'm going to open up a 4. And there it is, 2.9787. 2.9787. All right. Now I need the acceleration. Guys, you're taking a calculus test. Show them that you got the acceleration by taking a derivative of. So just you don't have to be fancy. You just go a of 4, which equals v prime of 4. There it is. You just connected the acceleration to derivative of velocity. And because this is a calculator section, do you got to show them the derivative by hand? No, you don't. You just give them, this is called a setup. You just show the setup, that the derivative of velocity is acceleration, and then give the number. So here we go. Math number 8, and then x, and then I'm going to put alpha trace y1 at x equals 4, and I'm going to push enter, and there it is, negative 1.164. Negative 1.164. All right. Am I speeding up or am I slowing down? Slowing down. So you're going to say particle is slowing down at t equals 4 since v of 4 is positive and a of 4 is negative. You could also say velocity and acceleration have opposite signs. So let me put that in parentheses. You could also say velocity and acceleration have opposite signs at t equals 4. So there it is. That's full credit, guys. Either one, it doesn't matter which one. You can say whichever one you feel most comfortable with, as long as you say correct math. Any questions? Bless you, bless you, bless you, bless you. No, for real, hit me, guys, hit me, because we need to improve on position, velocity, acceleration. Okay, we're good. All right. Let's see what letter B says. Find all times t on the interval between 0 and 3 when the particle changes direction. Justify your answer. Okay, I love it. Particle changes direction whenever the velocity changes. That's it. So just find where the velocity changes from positive to negative and negative to positive. You have a calculator, right? So all you're going to do, take your calculator and look at the time between 0 and 3. So go to y equals. There it is. This is my velocity. Click on window. Bless you. And you're just going to hover around between 0 and 3. So 0x min, 3x max. This is the time. X is the time. And you're going to hover around the x-axis. So let me see what my y equals was. My amplitude, that's a 2, 2, 2, 3. So 3. All right, so I see the max for this, guys, is a sinusoid. 2 plus 1 is 3. And the min, 2 minus 1 is 1. I'm sorry, 2. Oh, yeah, I definitely, 1 minus 2, so negative 1. So I'm going to hover between negative 1. You don't have to. You can just hover around the x-axis. Negative 1 and 3. Because that's my max and min. But you could just go negative 1 to 1. It doesn't have to be negative 1 to 3. Graph. And it only changes directions one time. Do you guys see that? So I'm going to go second calculate, and I'm going to put number 2, 0. And yes, left bound, enter, and then right bound, pass that where it crosses the x-axis. Does your graph look like my graph, guys? Okay. So I make mistakes too. So there it is, 2.707. And I don't think I need that time, so I'm not going to store it anywhere. So I'm just going to say particle changes direction at t equals, and I already forgot it, 2.707468. 2.707468 since velocity changes signs at this time value. And there it is. Done. That's it. That's full credit. Are we okay? Ask me questions, guys. We're good? Okay. Question 9 on the packetness. It's a position, velocity, acceleration question. Find the position of the particle at t equals 0. Guys, your equation will always look like this. There's other ways if you're not comfortable with this way, but hopefully you become automatic. Your position at 0 is equal to the position they give us. Let's see, what position did they give us? They give us at 4. So I'm going to write x of 4 plus the displacement. I'm given that 4. So from 4 to 0 of v of t dt. In case you're like, man, I don't like how that looks. Guys, look, there's other ways to do it. You can say, don't write this down because this is an alternate. Maybe you like the alternate better. Maybe you say, well, the integral from 0 to 4 is the displacement. And the displacement by definition is just x of 4 minus x of 0. See? And then which one do I have? I have this one. So I just take the displacement, subtract x of 4, change the symbol. Or I guess you can move that and that. So x of 0 equals x of 4 minus integral 0 to 4 of v of t dt. Maybe you like that better. Chop, how come this one has a plus and this one has a minus? Notice the limits. Notice the limits. I like this one in red better, guys, because to me, this is just automatic. The position given plus the displacement. But if you like the one in purple, that's fine. Does that make sense to you guys? Oh, ask me. I thought I saw someone nod, but maybe I was just hallucinating. Lopez, did it make sense or no? Yeah. Pina? Okay. All right, guys, just type it in. X of 4 is 2. So I'm going to go integral. So second quit 2 plus math 9. And I'm going to go from 4 to 0. I think that's what I wrote. Yeah, 4 to 0 of velocity. Alpha trace y1, and I put an x in here, push enter, and there it is, negative 3.815. Negative 3.815. X of 0 is negative 3.815. We'll look at the rubric in a little bit, guys. Find the total distance the particle travels from 0 to 3. All right, how do I get total distance? Integral from 0 to 4, this is total distance. And instead of writing velocity, I'm going to put what first? Absolute value. There it is. This is called a setup. You don't have to show anything by hand. What's up? 0 to 3. Good catch. I would have gotten it wrong. 0 to 3. I was still in the last problem from 0 to 4. The final total distance from t equals 0 to t equals 3. This is your lower limit. This is your upper limit. So 0 to 3. Thank you, miss. Everyone okay, guys? This is called a setup. Just show the calculator. I'm going to go math, number 9, 0 to 3. And then the absolute value button, you got to push math. And it's the one under number, NUM, and then the very first one, enter. Bam. See, there it is, absolute value. Alpha trace, make sure you practice, guys, so you guys know where everything's at. And then push X. Oh, not there. Not there. Right here. And bam. 5.301. 5.301. You can always put more digits, but there it is. I don't see any issues. Should we look at the rubric, see how we did? 2016 question 2. That one looked pretty straightforward. So 2016 question 2. Let's look at the rubric real quick. Your response, 2016 question 2. 2016. All right, here it is, 2016, and let's see. So 2 points, conclusion with reason. So there's either all or nothing. The particle is slowing down since the velocity and acceleration have different signs. Perfect. I would have liked it if they would have said at t equals 4, but that's fine. Letter B, did we get 2.707? Yeah, there we go. We got 2 points, guys. V of t changes positive to negative at t equals 2.707. Therefore, the particle changes direction at this time. Perfect. Letter C, they wrote what we wrote. Yeah, hopefully this is automatic for you. And we got negative 3.815. They gave you 3 points. Integral, use the initial condition and answer. So if you don't use your initial condition, but you did the integral, you got a point. That's cool. I think that's cool. And then letter D, 5.301, straightforward. So yeah, this one was just pretty straightforward, I thought. What do you guys think? Not bad, right? Okay, so hopefully we're getting better. All right, let's go to the next one, guys. The next one is no calculator. So let me close this guy. Bam. And let's see how we do. Don't worry, we're almost done. All right, this is from 2012. Between 0 and 12, a particle moves along the x-axis. So again, I'm moving either left or right. Left or right. The velocity of the particle at time t is given by, so here's my velocity equation. The particle is at position negative 2 at time t equals 0. Okay. When is the particle moving to the left? Ooh, I love it. And they're going to force you to know a little bit of pre-cal, but not extreme pre-cal. All right. Find where velocity is negative. That's when you're moving left. That's when you're moving left. This is for notes. I wouldn't necessarily write it like this on the AP exam. So let's see. V of t, let's find where this is 0. Cosine pi over 6t equals 0. It's not an extreme pre-cal, guys. Just a little bit of pre-cal. Bless you. Bless you squared. Oh, sorry. Cosine is 0 whenever cosine is pi over 2. So what will make this pi over 2 or 3 pi over 2? So I guess you could do it right here. You can say I need pi over 6t to equal pi over 2. Or I need pi over 6t to equal 3 pi over 2. Right? Because at the unit circle, Cosine is 0 at those two locations. So if you multiply this by 6 over pi, or hopefully, maybe I'm doing too much and you guys can already see it, you know. So t equals 3. Like maybe you guys can see it without having to do all this stuff. T equals, let's see, 3 pi over 2 times 6 over pi. The pi's cancel out. 6 times 3 is 18 divided by 2, 9. These are just my values where velocity is 0, guys. I think that's all of them between 0 and pi. So here's my velocity. So 3, 9. I guess another one's 12, but at 12 it doesn't matter because you're already right at the edge there. Because it's between 0 and 12, see? 12 pi over 6 is, actually, no, that's 2 pi. That's cosine of 2 pi is 1. 3, 9. Yeah, that's it. We still okay? Have I confused anyone, guys? Let me know, guys. All I did was just solve where the velocity is 0. All right, I'm going to pick a number between 0 and 3. I don't know. What's an easy number? 2? Yeah. Or I guess, yeah, 1 is fine. If I plug in a 1 there, cosine of pi over 6, positive or negative? Positive. I'm going to pick a number between 3 and 9. I guess like 6, because there's already a 6 down there. If I plug in a 6 in there, I get cosine of pi. Cosine of pi is negative. It's negative 1, but you just care about the sign. I'm going to pick a number between 9 and 12, like 10. So I'll write cosine 10 pi over 6, which reduces to cosine 5 pi over 6. Cosine 5 pi over 6, that's in quadrant 2. And that is also negative. Let me know, because I make mistakes all the time. Did I mess up or no? Oh, yeah, I did mess up. That's 5 pi over 3, and that one is positive. 365. Yeah, I messed up. I didn't do that on purpose. I promise I didn't, even if it looked like I did it on purpose. I'm just tired. Everyone is, I think. All right. Cosine of 5 pi over 3 is in quadrant 4. In quadrant 4, it's positive. So when am I moving to the left? Between 3 and 9. Here's how I would write it. I would just write particle is moving left on time interval, but you don't have to say it, they understand. On interval 3, 9, since v of t is negative on this specific interval. And there it is, guys. That's full credit. Particle is moving left on time interval 3 to 9, since velocity is negative on this specific interval. Done. Cool? Don't worry, guys. We're almost done. Letter B. Write, but do not evaluate, an integral expression that gives the total distance traveled by the particle from 0 to 6. How do I find total distance? Absolute value. And do we have to solve it? No. 0 to 6, absolute value. They already told you what v of t is. They give it a name, so you can just write v of t. Full credit. All right, here we go. Letter C. Oh, I thought that was the last one. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at t equals 4? Let's find the acceleration first. So a of t equals v prime of t. Make sure you connect it, guys. Connect it to velocity. And I'm going to take the derivative. What's the derivative of cosine? So negative sine. Keep the argument. Pi over 6t. Relax. We still have the chain rule. Times the derivative of the inside, the pi over 6t, which is pi over 6. You're going to go, let's see, a of t now equals negative pi over 6 sine pi over 6t. And then they want to, okay, so there it is. That's the first, find the acceleration of the particle at time t. So there's my first answer. Now they want to know, is the speed of the particle increasing, decreasing, or neither at t equals 4? All right, so for that, I need to find my velocity at 4. Did I already get that? No, right? Oh, you know what? We don't even have to do it. I already know that my velocity at 4 is what? Negative. So I'm just going to go velocity at 4 is negative. unless you really want to know the time, it doesn't ask for it. All they ask is the speed increasing, decreasing, or neither, and to explain. So I definitely need my acceleration. My acceleration at 4 is negative pi over 6 sine. And if I plug in a 4 pi of t equals 4 in there, 4 over 6 reduces to 2 pi over 3. Let me know if I'm wrong, guys, because I make mistakes all the time. Sine of 2 pi over 3. Is sine of 2 pi over 3 positive or negative? 2 pi over 3 is in what quadrant? 2. You don't even have to give the value, guys. What's positive times a negative? A negative. So I just wrote less than 0. You can write the number if you want. Just make sure you don't get it wrong, right? On the unit circle, 2 pi over 3 is square root of 3 over 2. So you can write square root of 3 over 2 times negative pi over 6. But here it is. I'm just saying that the acceleration is negative and that the velocity is negative. So since both of them are negative, what's the speed? What's happening to the speed? Increasing. So I'm going to write the speed, and I'm just using their language, guys. The speed of the particle is increasing since V of 4 and A of 4 have the same sign. Full credit. I haven't looked at the rubric, but we'll look at it in a little bit. Any questions, guys? All right, last one, letter D. Oh, ask me. I heard something. Find the position of the particle at t equals 4. All right, guys, that's it. Position. Hopefully by now this is starting to become automatic. My position at 4 is equal to the initial position given, which was at 0, plus the integral from 0 to 4 of v of t dt. Man, this one almost looks like the exact one from before. That was pure coincidence, guys. X of 0 was negative 2. So this time they want me to do it because you don't have a calculator, guys. So they're forcing you to do it. Negative 2 plus integral 0 to 4, and I'm going to write my v of t expression. Cosine pi over 6t. Cosine pi over 6t dt. All right, here we go. Negative 2, that's this one. Plus, and I'm going to put a bracket. Antiderivative of cosine is sine. So now they're seeing if you know the antiderivative. Sine of pi over 6 with a t on the side. Close it, and I'll wait for you guys to catch up. That's not it. We still have to do chain rule. So instead of multiplying by pi over 6, you're going to take the reciprocal. Multiply by 6 over pi. Is everyone okay with that 6 over pi, guys? And then I close my bracket, and I put a 0 on the bottom, and I put a 4 on the top. Sine of 0 is 0, so I don't have to worry about the 0. Does that make sense? All right, here we go. So I'm going to write negative 2 plus bracket. I do have to worry about the 4. 6 over pi sine of 4 pi over 6, which is 2 pi over 3. Let me know if I made a mistake. If you're scared, and I don't like saying this, but you can leave it like that, but your professor probably won't like that. So I'm just letting you know, this will take it, but your professor at your university might not. Let's give the right answer. Well, this is the right answer, but let's give the numeric answer. 6 over pi, giant parentheses, sine of 2 pi over 3. That's like 120 degrees. So the y value of the unit circle is square root of 3 over 2. So square root of 3 over 2. And then, I'll slow down, don't worry. 2 goes into 6 3 times. So that's what I just did there. Just did 2 goes into 6 3 times. Or 6 divided by 2 is 3. And here's your final answer. You can leave it like this. Negative 2 plus 3 square root of 3 over pi. You can also multiply that negative 2 by pi over pi to do a common denominator. Let's look at the rubric, guys, and let's see how we did. So 2012, question 6. 2012, question 6. All right. Let's see. Oh, I saw a decimal. Don't worry, guys. We're almost done. Nope, we did it right. Here we go. V of t equals 0 at 3 and 9. That considers, look, check it out, guys. They gave you a point for considers V of t equals 0. So if you wrote V of t equals 0, they give you a point. The particle is moving to the left, where velocity is negative. This occurs between 3 and 9. Perfect. We said the same thing. Letter B, we got that 1 point. It was 1 point. Acceleration is negative. Look, you could have done numeric. We didn't even bother. We just said negative. Velocity of 4 was negative. We didn't bother doing the numeric. So because the speed is increasing at t equals 4, because velocity and acceleration have the same sign. Perfect. Letter D was worth 3 points. 1 point for the antiderivative. We got the 1 point. Uses the initial condition. We got the 1 point. And answer. -2 plus 3 squared root of 3 over pi. We got it. Do we feel better with position, velocity, acceleration, guys? Now, be honest, because this I dictate based off of what you guys tell me. Was this helpful, or did you feel like we just wasted 30 minutes? Be honest with me, guys. Was this helpful? All right. We're done. You have an hour, 10:29. You have an hour exactly. Please do calculus with your hours, guys, if you know old flashcards or UH or whatever it may be. So take care of business. We're done, guys.